Okay, 10.3 is a 3-day lesson, only because I needed to separate the things out. Today we're going to look at the 4 basic level operations with radicals. It's important that you get a grasp on these for the day because every lesson is going to apply what we're learning today or what we're using on the previous lesson onto the next lesson. So again, make sure you get that. Essential question is, how does this relate to variable operations? In terms of the main 3 operations of addition, subtraction, and multiplication, your experience working with variables is useful. So again, be sure to listen to the connection that I try to give you so you can make the proper decision when the time comes. Addition and subtraction, we learned a long time ago we can only add and subtract like terms. For example, we know that 4x and 8x makes 12x. We know that 5y minus 9y makes negative 4y, and the reason we can put that together is because you have x and x, y and y. That we cannot do 3x plus 2x squared because those are 2 different variable items, and so therefore you cannot put that together. The same thing holds when you go to add and subtract radicals. You can only add or subtract what I would call like radicals. So looking at these examples, if you were asked, I think these are on your notes, 4 root 5 and 7 root 5, the answer would be 11 root 5. And the key thing to remember there is that it's not 11 root 10, just like this did not turn into 12x squared or 4y squared. The variable portion stays the same because you're simply saying that you have 4 root 5s and 7 root 5s to make 11 root 5s. Same thing here, 9 root 6 minus 14 root 6 would be negative 5 root 6 because again the root 6 stays the same. We simply do our 9 minus 14. If you remember that I called our last lesson the foundation to our chapter, that's because the tricky questions can be kind of pushing. So when you see a question like this, you have to assume that you can do something because you have a plus or minus, and they wouldn't just give us a question like this. So what we have to do is, and you have to kind of verify this on your own, but what we have to do is simplify this to make it better. What I know about 8 is that it's 4 times 2. 4 turns into a 2, and again, for you to verify this on your own, I know that this would be 10 root 2. Again, do the work on your own if you need to, but if you trust me, just know that 5 root 8, after I do the simplification of this like we did last section, is going to turn into 10 root 2. I know that 27 is 9 times 3. 9 turns into a 3 when we take it out of the root, so that makes 9 root 3 because the 3 stayed. I know that 75 is 25 times 3. Again, perfect squares, 25 turns into a 5, so minus 30 root 3. So again, you can verify these on your own if you need to in terms of where these other numbers came from, but all I did was applied what we learned in 10.2 to convert these 3 things and simplify them. Once they're simplified, you recognize we actually have 2 terms that can be put together. And so this simplified would be 10 root 2 minus 21 root 3. And that would be the answer that you have to do. But again, the foundational work of simplifying, and simplifying is what's going to cause your issue with this. It has nothing to do, in my opinion, with your ability to put 4 root 5 with 7 root 5. It's that when you see this question, you are probably weak at turning these things into their simplified forms. So don't overanalyze your issue. Just make sure you understand that your issue is probably going back to 10.2 and then get some more practice and make sure you get that understood. But as long as you remember again to rely on your understanding for variable work, it should be fine. Again, just remember that the radical part does not change. Practice well, and again, ask as many questions as you need to. Even if you feel like you're asking me too much, I do get paid to help you out. Multiplying radicals is easy, but getting the correct answer can be challenging. I know that sounds crazy because I did say it's easy and challenging at the same time. But if you think about the rule for multiplying radicals, and you might want to write this on your notes, I think I forgot to put it on there. Outside times outside, inside times inside. In other words, the outside value is found by multiplying any value or values that are already outside. And the inside value is found by multiplying any value or values that are already inside. When we did, again, variable work, 4 times 5x, we took the 4 times the 5 because those are actual numbers, and we attached the x. So again, 4 times 5, which are numbers, we multiplied, and then we brought down the x. In t times 5t, we multiplied the t's because they are both variables, and the 5 just came down giving us 5t squared. Again, you have done this before in terms of multiplying mixed types of values. But again, notice how the matched parts that belonged, or how we matched the parts that belonged. The same thing goes for our work with radicals. Unfortunately, your potential with your potential weakness with simplifying will cause you to miss points on any assessments. Let's just look at some examples and again try to get you some practice so you'll be ready to go. 3 root 5 times 2 root 7. You have to understand again that the value types are what go together. 3 and 2 are both outside values. Those multiply to make 6. 5 and 7 are both outside values. They go to make 35. The reason why I taught you both methods of simplifying is because right now, if you try to break this into prime factors, it might work quickly, but it might not work as quickly. Whereas with the 4, 9, 25, I know 4 doesn't go. I know 9 doesn't go. I know 25 doesn't go, and 49 is too big. So I already know just by checking those 4 numbers that this is simplified as far as it can go. And again, that's where the strength of both of those come in. I believe that the prime factorization is probably the safest way to convert them, but I think that using the perfect squares is the easiest way to check them. Looking at B, your only outside value is 5, and so we just bring it down just like we did with the other problem on the variables. But we have an inside 6 and an inside 10, which makes 60. And again, on your quick check, I know that 4 goes into 60, which means that this can be reduced. And again, if I use the simplified version, 4 times 15, and again, you can verify this for yourself, but 4 times 15 makes 60. 4 is a perfect square that turns into a 2. 2 comes out and multiplies by 5, giving us 10 root 15. And again, the beauty of being able to check is that I can make sure I'm right by doing 5 root 60, which is that, and I can do 10 root 15. I can even go as far, if I know how to program my calculator, to do 5 root 6, and notice how that's a parentheses there, times root 10. And again, notice how the answers match. So again, if you learn to program your calculator, you can actually check your answer all the way through. Again, the key thing there is this would be your issue more than anything else. I think it's easy to get from here to here, but you have to know how to get from here to here on your own. And then 6 root 7 times 2 root 7 is going to have us multiply the outsides to make 12. Root 7 times root 7 makes root 49. And again, this is where your simplifying comes in. And this is also where you need to make sure you understand that anytime you take a root times itself, it's probably going to come out as itself, because notice that the square root of 49 actually turns into a 7. You would then multiply that 7 times 12, getting the answer of 98. Or if you're not sure what to do, again, as long as you have a calculator, but I would try not to rely on the calculator, you could just, as long as you know it's a perfect square, you could just type in, 84. But you could just type in that part and get your 84. But again, pay attention to the fact that I messed up, but my check is what kept me from moving on with the wrong answer. So again, your check of using the calculator, you are allowed to use calculators on this test and on these assessments. To not check them when you should know how to program them is just not smart, because again, you notice I did this in my head, which was obviously wrong. But then while talking you through the process of checking your answer, when I typed it in, it actually told me what the answer was, because I forgot that 7 times 2 is 14, not 18, and that was absolutely wrong. But again, this is typically not assessed directly, but the importance shouldn't be overlooked, because the part where it is assessed is in distributing. So the last basic level of work that we're doing today is pretty much just the distributive property. But again, to do the distributive property, you must understand how to set up your work. So you have root 7 times 3 root 7 plus root 7 times 2 root 5. From there you multiply. This turns into 3 root 49. I'm sorry, that's negative 2 root 5. And then minus, because that would be negative, 2 root 35. And at this point you have to know how to simplify, because if you don't know how to simplify, you're stuck. I know that 49 is a perfect square, and just like I said, I know 49 is going to turn into a 7, which I know I'll multiply by a 3 to get 21. Doing my quick check, 4, nope, 9, nope, 25, no, 49 is too big, which means that this is already simplified, and so that would be my answer. 21 minus 2 root 35 is it. Alright, and then the last question we're going to talk about today is this. This becomes 2 root 6 meeting root 3 plus 2 root 6 meeting negative 3 root 2. I want you to understand that if you go back to our distributive property lesson, I'm setting everything up the same. The only difference is I have to make sure that I know how to simplify these things because that's where it comes in. This turns into 2 root 18 because the outside number is 2 and 6 times 3 is 18. I know that a positive times a negative is negative. This turns into 6 root 12. Root 18 I know has a 9 in it, and it's actually 9 times 2. 9, of course, when it comes out turns into a 3. 3 times 2 makes 6. Root 2, again, you might want to verify that for yourself because that is part of where your skill has to come in. 12, I know to be 4 times 3. 4 being a perfect number that comes out as a 2 would multiply by 6, making it 12 root 3. And this is, again, where the complex part is. I honestly believe that it's easy, as long as you're disciplined, it's easy to link these two things up. It's easy to link these two things up. I believe it's pretty easy to do your multiplication to get your 2 root 18 and your negative 6 root 12. Where you're going to have issues if you don't practice is turning this into its proper form, which is 6 root 2 minus 12 root 3. And again, that is where you need to focus your efforts because that's really where the problems start to occur. So other than that, I don't know if your Math Excel works today, but if not, I have a worksheet for you. But other than that, just go ahead and get some practice. And again, make sure you're asking questions on this so that we can go ahead and keep moving towards getting done with this chapter and with this stuff for the year. Good luck.